Next topic, let's have a discussion on capacitance of three-phase line with unsymmetrical spacing. Okay, this is unsymmetrical spacing, similar direction we are running inductance of three-phase line. Here consider a three-phase line with unsymmetrical spacing, three conductors, conductor A, conductor B and conductor C. Each conductor spacing is different here. From a conductor A to B, distance is D1 to 2. Here 2 to 3 and here is 3 to 1. Okay. Unsymmetrical spacing between the conductors. The effect of unsymmetrical between the lines is a small and calculation are carried out by considering transposition of lines. Already you know that unsymmetrical spacing we will get the different equations. So we are going to transpose each conductor. So each conductor transposition for first position, second position, third position. Finally, for the conductor A, we have to take the average of 3. Okay, like that in the inductance we are done. So like that here also capacitance, the same thing we are going to do. When the conductor A is in the first position, conductor B is in the second position, conductor C is in the third position. So here conductor A is first position, this is second position, this is third position for the C. Okay. VAB is equal to what? VAB between A conductor and B conductor when A is at the first position. Okay, VAB when A conductor is at the first position, that is 1. Okay, 1 divided by 2 pi epsilon, take it common. Here B and VB, already I said that reverse order of resistance. QA line D1 to 2 divided by R. Here R divided by D1 to 2. Okay. See here VAB for the first position, D divided by R and here R by D between A and B conductors. Okay. Next for the C conductor, how to take the distance QC into ln of C, which is the second one here, VAB. B is the second, A is the first one. So B with respect to C divided by A with respect to C, you have to take it. Okay, therefore D23 divided by D31. Therefore, for this D23 divided by D31, I have to take for the QC with respect to VAB. Getting? See here in the equation, when the conductor A is at the first position, see, plan of D2 divided by D31, because B conductor is second, is A conductor is the first one. So for the C conductor, take B and C divided by A into C. Okay. Next, when A is the second position, B is the third position, C is the first position, and next A is the third position. C, for the reference, we go through this diagram. When A is first position, B is second position, C is third position. That is the first concept, first equation. QA into line D12 divided by R, and for the QB this is reverse, R by D12. For the QC, D23 divided by D31. Remember, B divided by A you have to take, because here B, second is B, first one is A. With respect to C, you have to take B and divided by A. BC divided by AC. D23 divided by D31. Okay. Next, when A is shifted to the second position, A position is shifted to the second position, B is to the third position, C is to the first position. Therefore, AB at the A is at the second position. Therefore, QA into ln of D23 divided by R plus QB into ln of R divided by D23 reverse. Okay. Then QC with respect to QC, VAB is equal to BC divided by AC. D231 divided by D12. Here AB means B is second, next A is first. Second divided by first distance. D31 divided by D12. Right? Here I have written clearly. Go through that. Next, when A is shifted to the third position, see, A is shifted to the third position, B is to the first position, C to the second position, right? Then VAB 3, potential between A and B when A conductor is at the third position, QA into ln of D31 divided by A plus QB ln R divided by D31. For the QC, with respect to QC, D12 divided by D23, right? So, You can take a cyclic order. Last see previous equation. Here I will show you the clearly how to take the cyclic order without diagram. See, here is 1 to 2, 1 to 2, reverse, both are reverse, right? D by R by D. Next 1 to 2, next 2 to 3, 3 to 1. Next, here 1 to 2 is over, 2 is left, right? Lastly, then it starts from 2 to 3, cyclic order. Here is reverse. Next, here is 3 left, right? 3 to 1, next 1 to 2. Okay, here 2 to 3 is right, here 3 to 1. Next, here after 1, 1 to 2, 2 to 3. Getting? So, next is potential for the A conductor in all the three positions. Take it average. VAB is equal to add 3 equation divided by 3. VAB1 plus VAB2 plus VAB3 divided by 3. So 1 by 2 pi epsilon, take it common, 1 by 3 also common. Add all these 3. D1 to 2, 2 to 3, 3 to 1. Here is reverse order divided by R cube. Here is reverse for QB. And QC here, right, see here D1 to 2, 2 to 3, 3 to 1. Divider also same term. So get cancelled. This term is 0. Line of 1 is 0. This term is 0. Next. QA plus QB here reverse order. Okay. Shall I take here this D1 to D2 to 3, 3 to 1. This is a D equivalent, cube root of D equivalent. See here R raised to 3 means you have to take R cube. For this here root you have to take, right, D equivalent divided by R. Okay, D equivalent divided by R for this term. So substitute here D equivalent term. Here is reverse order. Next, QA plus QB, right? Here this is for the VAB, and for the VAC QA plus QC. Next, here D equivalent by R, here R by D equivalent, reverse order. Add these two terms, VAB plus VAC is equal to, already you know that with respect to the neutral 3 times, I said I directly have to take the equation. A, B, C, 3 phase with respect to neutral 3 times with respect to neutral VAN. Okay, VAN is equal to 1 by 2 pi epsilon, right here VAB plus VAC. QA, this is 2 times QA, QB plus QC into line of R by D equivalent, take it common. QB plus QC is equal to minus QA, substitute here. Minus Q into R divided by DQ, take it minus inside, you will get reverse order D by R. Okay. Next, this is 2 plus 1, 3 times. QA divided by 2 pi epsilon, line of D equivalent divided by R. Capacitance of phase conductor A to the neutral will be Q divided by V. With respect to A conductor, that is QA divided by VN. This is the equation. Previously we have done D by R, here D equivalent divided by R. Okay. Let's see the problem. Determine capacitance and charging current IC for a transmission line. They have given operating at 132 kV. They have given voltage, line voltage. The conductor diameter D is 0.8 cm. They have given distance D1 to 2, 2 to 3, 3 to 1. Okay. This is find the equivalent 1 to 2, 2 to 3, 3 to 1. Cube root of those, you will get the equivalent diameter they have given. Take it from that, find the radius. Write the capacitance formula, substitute here. You will write the capacitance. Phase line voltage given, find the phase voltage. Okay. Next, 50 hertz consists of 3 conductors. Diameter is given 21. Okay, find the radius. A to B, B to C, C to A. They have given different distance they have given by spacing, so it is unsymmetrical spacing. Find the D equivalent is equal to cube root of 2.5, 4.5 and 3.5 into. So D equivalent you will get, okay, substitute here D equivalent divided by radius, you will get the CAN. Okay. Capacitance that is XC is equal to 1 by 2 pi FC. X is equal to, you will get, right. If they ask for charging current IC, IC is equal to V divided by XC, that is V phase divided by XC. Next, they have given here different spacing, 5 meter, 5 meter and 8 meter. They have given diameter 0.8. Inductive reactance they have given 25 kilometer long per kilometer per phase. Calculate the capacitance and capacity reactance of the transmission line. Here both they have asked given here inductance and also capacitance. For the inductance, you have to find the R dash. You know that 0.778 into R dash for the inductance, R for the capacitance. DAB, BC, CA, they are given. Find the equivalent. For the inductance, use the formula, find the LA. For the 25 kilometer long transmission line, multiply 25 overall the transmission line length. LA is equal to, okay, total inductive reactance XL is equal to, okay, and the XL is equal to 50 hertz frequency they have given. Next, similarly capacitance also, the equivalent then divided by radius, okay. Then capacitance for the 25 kilometer long transmission line, multiply 25 into, you will get for the overall transmission line length, then X is equal to 1 by 2 pi FC, frequency they have given here, okay. A 3-phase 50 hertz 66 kV line they have given, horizontally placed. It is not a triangular shape, it is horizontally placed. Diameter they are given, D is equal to 1.25. The length L is equal to 100 km. Find the capacitance per phase and charging current IC. See here, conductor A and B distance is 2 meter, B to C is 2.5 and C to A is 4.5. 2 plus 2.5, 4.5 distance, unequal spacing. Find the D equivalent, cube root of 1 to 2, 2 to 3, 3 to 1. Okay, R is equal to, from the diameter find, substitute in the formula. Okay, we will get the capacitance. Therefore, XC is equal to 1 by 2 pi FC. IC is equal to V phase by XC. V line is given 66 divided by root 3. We will get the V phase divided by XC. We will